Hello, hi everyone. Welcome to the Student Brand. This is your Sivas. Today topic is light reflection and refraction. So in the previous video we discussed about light reflection. So in this video we'll discuss about light refraction. Light refraction. So light refraction. Refraction is nothing but so the bending of the light ray at the interference of the two media is called refraction of light. The bending of the light ray at the interference of the two media is called refraction of light. Light ray is moving from one medium to another medium. So when it is moving from one medium to another medium, at the interference of the two media, it changes its path. At the interference of the two media, it changes its path. Or the path of the light changes at interference of the two media. Or bending of the light ray, so takes place at the interference of the two media is called refraction. So refraction, what is that called? Refraction. Okay, so here I am taking like this is a rarer medium, a denser medium, rarer medium, denser medium. Sir, what is rarer medium and what is denser medium? So the bouncing back of the light from the reflecting surface is called reflection of light. So coming to refraction, so the path of the light changes when it is moving from one medium to another medium. Okay, so that is called refraction. So rarer medium, speed of light is more in the medium, that is rarer medium. Speed of light is less in the medium, that is denser medium. So when it is moving from rarer to denser, when it is moving from rarer to denser, the path of the light changes at the interference of the two media. The path of the light changes at the interference of the two media is called refraction. 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 So incident ray, normal line, normal line, normal line, normal line, normal line. This incident ray. So refracted ray. Okay, so refracted ray, yes ma. So I'll explain refracted index. So wait some time. So now we are so coming to the concept only. So refracted index I'll explain. So here this is the incident ray, incident ray, incident ray. The light ray which is incidenting on the surface is called incident ray. The light ray which is refracting to the surface is called refracted ray. Refracted ray. Okay, so here you can observe the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. So here I am saying the angle between incident and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle of refraction. What exactly the refraction? The bending of the light, the interference of the two media. The bending of the light ray at the interference of the two media is called refraction of light. So here you can observe this is a rarer medium, denser medium. So the path of the light changing at this point. That is the interference of the two media. Yes. So here we can take air is a rarer medium, water is a denser medium. Suppose if I take air is a rarer medium, water is a denser medium. Air is a rarer medium, water is a denser medium, light ray is coming from rarer to denser, light to water. At interference of the two media, it bends towards the normal line. Towards the normal line. The path of the light changes at the interference of the two media is called refraction of light. Refraction of light. Refraction of light. Yes. Here the angle between incident ray. So and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. Angle of refraction. Angle of refraction. Angle of refraction. Now coming to loss of, and here one more point I will discuss. So here if the light ray is passing from rarer to denser, it bends towards the normal line. Yes or no? If the light ray is passing from rarer to denser, it bends towards the normal line. If the light ray is passing from denser to rarer, denser to rarer, denser to rare, it moves away from the normal line. It moves away from the normal line. If the light ray is passing from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. It moves away from the normal line. Yes, yes. When it is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. The path of the light ray changes at the interference of the two media when it is moving from one medium to another medium, one medium to another medium, one medium to another medium. Yes, so here you can see this is a rarer medium, denser medium. Light rays passing from denser to rarer, denser to rarer, denser to rarer. The angle between incident and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle of refraction. Are you understanding? Are you listening? Are you observing? Are you focusing? Yes or no? If you're there, just click on like button, share and subscribe my channel. Share to your friends. Ask them to join to the live class. Physics is going on. Very important concept that to refraction, light refraction. Here is very sensitive topics will come. That to refractive index. So prism, lens, image formations, lens ray rules, power of lens, everything will be there. Just ask them to join to the class. Very important topics we are discussing. Just click on like button. No, so just if you click on like button, it will reach to the remaining students. They will also come and join to the class. Here class is going on, then they will learn physics. Just click on like button. Okay, so if the light ray is passing from rarer to denser, it bends towards the normal. If the light ray is passing from denser to rarer, it moves away from the normal line. So you need to understand one thing. You need to understand one thing. Here, if you observe one thing, there is this very important point. There is an important point is here. That is, if the light ray is passing from rarer to denser, it is bending towards the normal line. When it is passing from denser to rarer, it is moving away from the normal line. Yes or no? It is moving away from the normal line. Now, you can observe one thing here. So, in this case, angle of incidence is greater than the angle of refraction. In case 1, angle of incident is greater than the angle of refraction. In this case, angle of refraction is greater than the angle of incidence. Okay, so are you observing here? Are you observing or not? So here, why it is? So light ray is passing from rarer to denser, it bends towards the normal line. So here, light ray is moving towards the normal line, so angle is decreasing. So compared to angle of incidence. In this case, angle of refraction is greater than the angle of incidence. Because when it is moving from denser to rarer, it is moving away from the normal line. Angle of refraction is greater than the angle of incidence. Yes, of course. So now we will discuss about laws of refraction. Laws of refraction. Na 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 na. So coming to laws of refraction. Incident ray, refracted ray, normal line lies on the same plane. Yes or no? Incident ray, refracted ray, normal line lies on the same plane. Point number 1. Second point is sign of angle of incidence. Sign of angle of incidence the ratio of sine of angle of incident to sine of angle of refraction equal to constant. Point number one, incident ray, refracted ray, normal line lies on the same plane. Second point is the ratio of sine of angle of incidence. The ratio of sine of angle of incidence to sine of angle of refraction equal to constant, that is nothing but refractive index. Refractive index. Refractive index. Incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies on the same plane. The ratio of sine of angle of incident to sine of angle of refraction equal to constant. Constant. These are called laws of refraction. Laws of refraction. Laws of refraction. Yes. So now, laws of refraction. So what is the refractive index? What is the refractive index? Can you say me what is the refractive index? Refractive index is nothing but n equal to c by v. Refractive index is nothing but n equal to c by v. Speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium is called absolute refractive index. Absolute refractive index is nothing but n equal to c by v. Yes. Absolute refractive index equal to n equal to c by v. So coming to relative refractive index. Sir, what is relative refractive index? Absolute refractive index. Absolute refractive index is n equal to c by v. N equal to c by v. So here you can see this is a rarer medium, denser medium. Light ray is passing from rarer to denser. Yes or no? Rarer to denser, rarer to denser. Angle of incidence, angle of refraction, n equal to c by v, n equal to c by v, n equal to c by v, n equal to c by v. Refractive index, n equal to c by v. The ratio of speed of light in vacuum by speed of light in medium is called refractive index. Refractive index, that is called absolute refractive index. The ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. Do you know the relative refractive index? So n1 to equal to n1 by n2, that is equal to v2 by v1. That is equal to v1, v2 by v1. Why it is like that? You know right, this one. N is inversely proportional to velocity. N is inversely proportional to velocity. N is inversely proportional to velocity. N1 by n2 equal to v2 by v1. n1 by n2 equal to v2 by v1 because n is inversely proportional to velocity. N is inversely proportional to velocity. So the refractive index of medium 1 with respect to medium 2, n12 equal to n1 by n2, that is equal to v2 by v1. Absolute refractive index is n equal to c by v. N equal to c by v, that is nothing but absolute refractive index. Relative refractive index is nothing but n1 by n2 equal to v2 by v1. So n1 by n2 equal to n1 equal to n1 by n2 equal to v2 by v1. v2 by v1, yes, that is nothing but relative refractive index. This is relative refractive index. Do you know the absolute refractive index? Absolute refractive index is nothing but C by V. C by V. Absolute refractive index is C by V. N equal to C by V. That is absolute refractive index. That's enough. In that case, from that, you can take one thing. What is that? N is inversely proportional to velocity. N is inversely proportional to velocity. From that, we can write N12. N12 we can write N1 by N2, that is equal to V2 by V1. How can we write? Because I mentioned over here, right? N is inversely proportional to velocity. N is inversely proportional to velocity. N is inversely proportional to velocity, so that we can take N1 equal to V2 by V1. Shall I take like that? And one more thing here you can observe. N2 by N1. Can I write like this? V1 by V2. Shall I write like this? Yes or no? Is it possible or not? Yes, it is possible. How it is not possible? Because I mentioned over here N is inversely proportional to velocity. N1 equal to N1 by N2, that is nothing but V2 by V1. N2 equal to N2 by N1, that is nothing but V1 by V2. How it is possible? Yeah, very important point it is. Absolutely. I'm saying here no. Absolute refractive index is equal to N equal to C by V. N equal to C by V. Relative refractive index is nothing but N1 to N1 by N2 equal to V2 by V1. N2 equal to N2 by N1 equal to V1 by V2. That is about absolute refractive index and relative refractive index. Absolute refractive index and relative refractive index. Next, I will explain about this is Snell's law. Snell's law is nothing but so incident ray, refracted ray, normal line lies on the same plane, and the ratio of sine of angle of incidence to sine of angle of refraction equal to constant. That is also known as Snell's law. Absolute over relative over, right? Now I will explain about refraction through glass slab. Refraction through glass slab. When light ray passes through the glass slab, how it takes place, how refraction takes place, I will explain. So are you all ready? Just you can click on like button, share to your friends, ask them to join to the class, because physics class is going on. How? Physics class is going on. Okay. So here I am considering like this. So refraction. We are discussing refraction only, right? So if you are discussing refraction, yes or no? We are discussing refraction, right? If we are discussing about refraction, then without discussing critical angle, total internal reflection, how it is possible to go to glass slab? How it is possible? We have to discuss about critical angle and total internal reflection. So how we have to draw the diagram? So I'll show you. Wait. So here I'm taking like this. This is a rarer medium. Yes or no? This is a denser medium. Yes or no? So if the light ray is passing from rarer to denser, if the light ray is passing from rarer to, what happens generally if the light ray is passing from rarer to denser, it bends towards a normal line. Yes or no? We know that. If the light ray is passing from denser to rarer, how it will happens? So it moves away from the normal line. We know this, right? So generally if the light ray is passing from rarer to denser, it bends towards the normal line. We know that. If the light ray is passing from denser to rarer, it moves away from the normal line. That also we know that, right? But one thing is here. That is, so you keep on sending the light ray from denser to rarer. But at certain angle of incidence, the refracted ray passes, gauges or moves along the surface. Yes. So refracted ray passes or gauges or moves along the surface. that angle, at certain angle of incidence, the refracted ray passes, or moves along the surface. That angle is called, critical angle. So here I am considering like this. This the incident ray. I am taking here this the normal line. Okay. So the refracted ray passes or gauges along the surface. Okay. This is called at certain angle of incidence. The refracted ray passes or gauges or moves along the surface. That angle of incident is called critical. That time, and one more point is here, the refracted ray makes 90 degrees with the normal line. Yes, it makes 90 degrees with the normal line. So here you can see it is making 90 degrees with the normal line. Yes or no? At certain angle of incidence, the refracted ray passes or gauges or moves along the surface. The angle between refracted ray and normal line is called 90 degrees. Okay. Otherwise, here you can observe. So this I am taking like this. It is passing. Keep on it. We are sending the light ray. You keep on sending the light ray. Okay. At certain angle of incidence, the refracted ray passes or gauges or moves along the surface. Or refracted ray makes 90 degrees with the normal line. That angle is called critical angle. So one more light I am taking like this from your refracted ray, from denser to rarer. One light I am taking from denser to rarer. So in the rarer medium, the refracted ray makes more than 90 degrees, more than critical angle. Then the light ray will reflect back into the same medium. So I am taking here. So here you can observe this the incident ray. So the refracted ray makes more than 90 degrees. Then it will be reflected back into the same medium. Okay, so here you can observe the angle between normal line. So this is 90 degrees and this one is theta. So what is this angle? Angle of incident, angle of reflection. So here you can observe one thing. The light ray is moving from denser to rarer. At certain angle of incidence, if the refracted ray may passes or gauges or moves along the surface, that it makes 90 degrees with the normal line. So that angle is called critical angle. So if the refracted ray makes more than 90 degrees plus theta, more than 90 degrees, then light ray reflect back into the same medium. This reflection is known as, this type of reflection is called total internal reflection. Okay, generally what happens if the light ray is passing from denser to rarer, it moves away from the normal line. We know that. So what is refraction? So the bending of the light ray at the interference of the two media is called refraction of light. The bending of the light ray at the interference of the two media is called refraction of light. If the light ray is passing from rarer to denser, it bends towards the normal line. If the light ray is passing from denser to rarer, it moves away from the normal line. We know that. We know very well about it. But one thing is here. So if the light ray is passing from denser to rarer at certain angle of incidence, At certain angle of incidence, the refracted ray passes or gauges or moves along the surface. Along the surface, that angle is called critical angle. That angle is called critical angle. And so light ray is passing from denser to rarer. Light ray is passing from denser to rarer. The refracted ray makes more than 90 degrees. The refracted ray makes more than 90 degrees. Then light ray reflect back into the same medium. The light ray reflect back into the same medium. So 90 plus theta more than 90 degrees, so then it will be reflected back into the same medium. This phenomenon is called total internal reflection. Total internal reflection. At certain angle of incidence, the refracted ray gauges or passes along the surface making 90 degrees with a normal line. That angle is called critical angle. The phenomenon of reflecting the light or light rays passing from denser to rarer. In the rarer medium, it makes more than 90 degrees. Then light ray reflect back into the same medium. Okay, so I hope it is very clear. So this is about critical angle and total internal reflection. Critical angle and total internal reflection. I hope it is very clear about it, right? So next, now it is time for discussion of glass slab. Now we have to discuss about glass slab. Yes. So we know till now we discussed about refraction. Light is passing from rarer to denser, denser to rarer. Okay. So laws of refraction, that is nothing but Snell's law. The ratio of sine of angle of incident to sine of angle of refraction equal to constant, that is nothing but refractive index n equal to c by v, that is nothing but absolute refractive index n12 equal to n1 by n2, that is equal to v2 by v1. We know that n is inversely proportional to velocity, that's why we discussed about that. Absolute refractive index and relative refractive index, those are completed. Now we are going to discuss about glass slab. Now we are going to discuss about glass slab. Be ready for it. So now we are going to discuss about glass slab. So here you can see incident ray. So this is about refracted ray, incident ray, refracted ray. This is a refracted ray, and so we are taking the emergent ray. So this is a normal line. Okay. So we are extending the incident ray. We are extending the incident ray. So this one. So we are extending the incident ray. The angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Okay, so angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. So refracted ray, angle between refracted ray and normal line is called angle of refraction. Angle of refraction. Okay, and the angle between emergent ray and normal line is called angle of emergence. Angle of emergence. So we are extending. So we extended this incident ray. This incident ray is extended like this. That is the initial direction of the incident ray. Initial direction of the incident ray. The angle between emergent ray, the distance between emergent ray and the initial direction of the incident ray. The distance between emergent ray and initial direction of the incident ray is called lateral shift. Yes, lateral shift. The distance between emergent ray and initial direction of the incident ray is called lateral shift. Lateral shift. Or we can also say lateral displacement. Lateral shift or lateral displacement. The distance between emergent ray and initial direction of the incident ray is known as initial direction of the incident ray is called lateral shift. The distance between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. The distance between emergent ray and initial direction of the incident ray is called lateral shift. The distance between emergent ray and initial direction of the incident ray is called lateral shift. Coming to the vertical shift. Okay, so here you can see the beaker. So this is a beaker. Okay, so I'm taking one beaker like this. La, 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 la. So I'm taking one beaker. So the person is standing over here. So a coin is placed at the bottom of the beaker like this. A coin is placed at the bottom of the beaker. Okay. So the coin position is not seen by him. Okay. So position of the coin is not observed. So it is not able to see in this position. So after pouring water, the position of the coin rises up. So the position of the coin is rises up. So this is the position of the coin and this actual position of the coin. This is the actual position of the coin. Actual position, this upper end position. Okay, so the red color is actual position of the coin and the blue color is upper end position of the coin. The distance between actual position and upper end position. The distance between actual position and upper end position is called vertical shift. The distance between actual position to upper end position is called vertical shift. I hope it is very clear. Are you understanding? So, the lateral shift is nothing but the distance between emergent ray and extended or initial direction of the incident ray. Emergent ray and initial direction of the incident ray is called lateral shift or lateral displacement or the distance between. So that is one point. So vertical shift is the distance between actual position to upper end position of the object. The distance between actual position to upper end position of the object is called vertical shift. Okay, so now we are placing the pencil. If you place pencil, so I'm taking the pencil here like this. Okay, so at the interference between water and air. So the interference between water and air at this position, the pencil appears to be bent. Okay, so at this position the pencil appears to be bent. So actually this is the actual position of the pencil, but at the interference between water and air, so the pencil appears to be bent due to refraction of light. I hope it is very clear, right? Now, so even you place lemon inside of the water placed in the glass tumbler or glass, you can see the lemon, it appears bigger. So when you take a glass of water, okay, and place lemon inside of it, then it appears bigger due to refraction of light. So these are very, very important. I hope it is very clear. Understood? So point number 1, the angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. So here you can observe this is the angle between emergent ray and normal line is called angle of emergence. Okay. So I hope it is very clear. And so I place the coin at the bottom of the beaker. Okay. So the person is standing, can't able to see the coin. After pouring water, so the coin position rises up. So the distance between actual position to apparent position of the coin is called vertical shift. The distance between actual position to apparent position of the coin is called vertical shift. I hope it is very clear, right? Yes. Now you can see one more here. So the lemon is placed inside of the what inside of the water beaker, or so you can take normal glass. So inside water is there. So take a glass of water and place the lemon inside of it. It appears bigger. Okay. So due to refraction of light. Due to refraction of light. I hope it is very clear. So this is about refraction. Refraction. Now, so we will discuss about lenses. Okay. So lens. Convex lens. There are two types of lenses: convex lens and concave lens. So convex lens, convex lens, convex lens. So convex lens is also known as converging lens. Here you can see this is a convex lens. So this is a part of the so here optic center, F1 to F1, F2 to F2 to F2. Okay, so convex lens is also known as converging lens. Concave lens is also known as diverging lens. Convex lens is also known as converging lens. Concave lens is also known as diverging lens. So here you can observe. So this side I am taking 1. So this side I am taking 2. Okay. So now optic center F1 to F1, F2 to F2. Now coming to the concave lens. Concave lens, concave lens, concave lens, concave lens. Okay, optic center F1 to F1, F2 to F2. So here so what is this one? Convex lens. What is this one? Concave lens. Convex lens, convex lens, convex lens. Convex lens, concave lens, concave lens. I hope it is very clear, right? Now, so convex lens is also known as converging lens, concave lens is also known as diverging lens. Why it is? So whenever light rays are incidenting on it, after refraction those light rays are meeting at one point. So here you can observe these light rays are meeting at one point here. Okay, so light rays are converging. So after refraction light rays are coming closer to the principal axis. That's why it is called converging lens. Whereas so concave lens, here you can observe concave lens, concave lens, concave lens. After refraction, those are moving away from it by extending this, by extending that one. So concave lens is also known as diverging lens. Convex lens is also known as converging lens. Converging lens, diverging lens. Okay, so now we will draw the ray rolls. Ray rolls of concave lens and convex lens. So now convex lens. So optic center, F1, 2F1, F2, 2F2. So light ray is coming from infinity, Light ray is coming from infinity. After refraction, it passes through focus. Light ray is coming from infinity. After refraction, it passes through focus. That is first ray roll. Second ray roll is light ray is passing through focus. After refraction, become parallel to the principal axis. And third one is light ray is passing through optic center. Light ray is passing through optic center. Yes. So one light ray I am taking like this. After that passes through focus. So this is the first one. First one. Coming to the second one. Optic center. F1, 2F1, F2, 2F2. Okay. So light ray is passing through focus. Light ray is passing through focus. After refraction it moves, it passes like this. After refraction it passes, moves. So parallel to the principal axis towards infinity. Yes, towards infinity. Coming to the third one, like this. So optic center, F1, 2F1, F1 to F1, F2 to F2. So F2 to F2. So light ray is passing through optic center. Light ray is passing through optic center. No deviation takes place. It moves like that only. It passes like that only. 1, 2, 3. 3 image. 3 ray rules. These are 3 ray rules. Coming to the next one. Concave lens. Concave lens. Concave lens. Concave lens. Concave lens. Optic center F1, 2F1, F2, 2F2. Light rays are coming from infinity. After refraction, those light rays are moving away from it, diverging. So here you can observe one light ray I am taking like this. After refraction, it is moving away from it. Point number 1. Coming to the point number 2. So light ray. Optic center. F1 to F1, F2 to F2. Light rays passing through focus. After refraction, moves towards infinity, become parallel to the principal axis. Light ray passing through focus. It become parallel to the principal axis and moves towards infinity. Okay. So next one, third one. Optic center F1 to F1, F2 to F2. Light rays passing through optic center. Light rays passing through optic center. It does not deviate. It moves in the same path, in the same direction. So like this, that is importance of the optic center. If the light ray passing through optic center, no deviation takes place. No deviation takes place. These are rare rules of convex lens and concave lens. Rare rules of convex lens and concave lens. Light rays coming from infinity after refraction passes through focus. Light rays passing through focus after refraction moves towards infinity. Parallel to the principal axis, will become parallel to the principal axis, moves towards infinity. Light rays passing through optic center. Light rays passing through optic center. No deviation takes place. Light rays coming parallel to the principal axis after refraction. Passes through focus. Light rays passing through focus after refraction become parallel to the principal axis. Light rays passing through optic center. No deviation takes place. No deviation takes place. So I hope it is very clear. This is about so now image formations. Image formations. Formations of image. Image formations by convex lens. Convex lens. Image formation by convex lens. So you're watching Student the Brand Physics CBSE Grade-10 Physics. Now we are going to discuss about image formation by convex lens. Yes. So welcome to the class. Now you can see. So optic center F1 to F1, F2 to F2. Object is at infinity. Where object? Object is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays. So one light ray I am taking like this. Another light ray is taking like this. After refraction, you can see object is at infinity. Image is forming at focus. So image is forming at F2. Nature of the image is real and inverted. Size of the image is highlight dimness. Highlight dimness. That is the first one. So first one. Coming to the second one. Object is placed. Optic center F1 to F1. Object is placed. 2F1, F1. So we can't take here. Right. F2 to F2. One light ray I am taking like this. After refraction passes through focus. Another light ray is passing through optic center. So the image will form between F2 and F2. So to F2, object is placed beyond to F1. Beyond to F1, image is forming between F2 and to F2. Image is forming between F2 and to F2. F2 and to F2. Nature of the image is real and inverted. Size of the image is, size of the image is, what about size of the image? Size of the image, size of the image is diminished. Tin, tin, tin. Tin, 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 tin. Tin, tin, tin. Da, 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 tin. Na, na, ni. Na, 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 na. Na, na, ni. Na, 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 na. La, li, la, li, la, la, la. So next one, third one. Third one, third one, third one, third one. So optic center F1 to F1, F2 to F2. Object is placed at 2F1 and F1. The image is forming at 2F2. How many light rays are required to form the image of the object? Minimum 2 light rays. One light ray I am taking like this, it passes through focus. Another light ray is passing through optic center, those light rays will meet here. Object is placed at 2F1, image also will form at 2F2. Nature of the image is real and inverted, and size of the image is same size, same size. Okay, coming to the fourth one. So can you guess and let me know where object is placed, where image is formed, what is the nature of the image? So now you can see object is placed. F1, 2F1, F2, 2F2. Object is placed between F1 and 2F1. Object is placed between F1 and 2F1. Where image is forming beyond 2F2. What is the nature of the image? Real, inverted, enlarged. Real, inverted, enlarged. One light I am taking like this. Passes. Another light is passing through focus. Focus. Object is placed between 2F1 and F1. Image is formed beyond 2F2. Image is formed beyond 2F2. Beyond 2F2. Nature of the image is real, inverted, and enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. Yes. Okay, so now fifth one. Ten, 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 ten. Na, 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 na. So here, optic center F1 to F1, F2 to F2. Object is placed at F1. So one light I am taking like this. It passes through focus. Another light ray is passing through optic center. So image will form. Object is at F1. Image is forming at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. So object is placed at F1. Image is formed at infinity. Nature of the image is real, inverted, and highly enlarged. Object is placed at F1. Image is forming at infinity. Nature of the image is real, inverted, and enlarged. Enlarged. That's enough. So coming to the sixth one. So sixth one I am taking here. So optic center F1, 2F1, F2, F2, 2F2. Yes or no? F2, 2F2. 2F2. Object is placed between F1 and O. One light I am taking like this, it passes through focus. Another light is passing through optic center. Another light is passing through optic center. Yes or no? Yes. So now, if we are extending those light rays, so these light rays are meeting here. These light rays are meeting here. Okay. Object is placed between F1 and O. Image is forming behind same side of the object. Nature of the image is virtual, erect and enlarged. What type of image is formed? Virtual, erect and enlarged. Virtual, erect and enlarged. Virtual, erect and enlarged. Same side of the object. Same side of the object. Okay. So these are the nature. So lenses, image formations. Once again observe. Object is placed at infinity. Image is formed at focus. So real and inverted and highly diminished. Object is placed beyond 2F1. Image is formed between F2 and 2F2. Nature of the image is real and inverted and diminished. Object is placed beyond at 2F1. Image will form at 2F2. Nature of the image real and inverted and same size of the object. Object is placed between 2F1 and F1. Image is formed beyond 2F2. Nature of the image is real and inverted. Size of the image is enlarged. Object is placed at F1. Image is formed at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Object is placed between F1 and O. Image is forming same side of the object. So nature of the image is virtual, erect and enlarged. Virtual, erect and enlarged. Very, very important. Very, very important. Next one. So we will discuss about concave lens. So next one, concave lens. Concave lens. So we'll discuss about concave lens. So in concave lens only two image formations are there. In concave lens only two image formations. So point number one. So here I am saying like this. Optic center. Yep. F1, 2F1. F2, 2F2. Object is at infinity. Okay. So where image is forming? At focus. Object is at infinity. Image is forming at focus. What is the nature of the image? Virtual, erect and diminished. Virtual, erect and diminished. How many light rays? One light ray I am taking like this. So here you can observe. Another light ray I am taking like this. So if you are extending this one, object is at infinity, image is forming at F1, nature of the image is virtual, erect and size of the image is diminished, highly diminished because point size image is formed at focus. Okay, so next one, two cases. sa 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 na ni na ni na 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 ni na 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 ni na na ni na na na. Only two cases are there. So here it will pass, the image will form between F and O. So object is placed between optic center and infinity. Image will form between F and O. Nature of the image is virtual, erect and diminished. Virtual, erect and diminished. Only two cases are there. So power of lens. The reciprocal of focal length is called power of lens. At the degree of converging of diverging of lengths achieved is known as power of lens. P equal to 1 by F. P equal to 1 by F. So power of lens is positive for convex lens. Power of lens is negative for concave lens. Okay. So this is very important. So make sure that you are practicing all these diagrams, concepts. So actually, so few questions. So we have to discuss, as I said. So important questions we need to discuss on these concepts. So do like, share and subscribe to Student the Brand. Share to your friends. Ask your friends to join to the class. Inform to everyone. Those who are there in the class. So inform to everyone. So make sure that everyone are attending to the class. So they'll get a good concept definitely. Okay, so concept will be in depth about concepts and related to problems, also related to concept. Problems also will discuss highly important concepts, very in-depth concepts we are going to discuss in the classes. So that will be helpful for the students to understand the concept in depth, and what type of questions they will ask and the concept also will discuss. So do like, share and subscribe to Student the Brand. Inform to your friends, ask your friends to join to the class. Inform to everyone who are there nearby, so available to you, those who are studying in grade 11, grade 12, grade 10. Okay, so and right from grade 6 to 12 they can join to the class, they can attend the class, they can learn the concept, but especially grade 10 physics, CBSE grade 10 physics topics are discussing at most. Okay, so thank you so much for joining and attending and listening my class. This is our Siva sir. Thank you so much. We'll see you in the next class. Thank you.